So anything about the last session that you can recall? Can anyone recall any points from the last sessions that we did? No? So yeah, we're just approaching towards the end of this unit. So this is the third learning objective, and tomorrow I'll be talking about the assignment discussion. So please have a good read of what was taught to you earlier, so that the session on assignment discussion is easier for you and you're able to grasp it here in a better way. So, okay, so we'll start here. So in this learning objective, we're basically talking about what are the processes involved in data collection. So the different processes. So it's the data collection methods, what are the types of data, analysis approach, statistical packages that exist there. There are many, so you might have access to some and not to all, so it depends. Grounded theory, what is validity, what is reliability, different problem statements, literature reviews, what is a conceptual framework, research questions, what are hypotheses, terms of reference, methodologies, timelines, how do you collect data, types of data, analysis approaches. This is the same thing. Then integration of expertise, values the best research evidence into decision-making processes for care, ethics, permissions and approvals, consent, confidentiality and anonymity. Then we'll talk about quality improvement, evidence, guidance and policies, and comparability, currency, validity, broadening of search, gaining of evidence and authenticity. Any questions in between, please let me know. So what is a literature review? It's a review of literature in literary terms. So you're actually reviewing stuff before you start writing it up. So for any project that you're doing, you need to have a literature review. That means we need to see that you've done your basic bits on understanding what you're going to delve into. So a literature review, it's an overview of the previously published work on a topic. So definitely there should be, whatever you're doing should be obviously not done before, but it is not possible that you would have any topic that has never been done before. It has been done, but might have been done in a different context. It's been done. So when you're doing research, you want something new out of it. You don't want to, like, for instance, I always give the example of smoking causes lung cancer, for instance. A person spends millions of pounds, asks for millions of pounds actually, makes a claim that he or she wants to, this researcher wants to find out the relationship or the association between smoking and lung cancer. Now we know that already. We know it through the biology. We know it through several studies that have been done for so many years. So we don't need to spend money or spend time more on this topic because we already know it. So there's something that we don't know that should be done, preferably. But then there will always be literature on that. So for instance, if you're finding some new drug therapy, I'm just giving an example. So you will have literature about that drug or about the disease that it cures. So that is called literature review. So you want to do your background understanding of the topic. So literature review is a piece of academic writing which demonstrates knowledge and understanding of the academic literature on a specific topic placed in the context. So literature review also includes a critical evaluation of the material. This is why it is called a literature review rather than just a literature report. So a report will just be describing something, that's it. But a literature review will be critical when you're writing it. It's a process of reviewing the literature as well as forming of writing. So what is a sample data? In data analysis, Sample is the practice of analyzing a subset of all the data in order to uncover meaningful information in a larger data set. Did any one of you get this point? I'm hoping not. So let's watch a video for this. Just bear with me. These are a bit tricky concepts. So yeah, this video will probably help you better understand this. Okay.
Hey everyone, welcome to this video on population and sample by Simplilearn. In this video, we will introduce you to the concept of population and sample along with some real-world examples of where they should be used. So let's get started. So what can you expect from this video? What's in it for you? First, we will answer the question, what is population? Then, we will explain the meaning of samples to you. We will look at some differences between population and samples by looking at some common examples, followed by looking at how we can collect data from a population and from a sample. So what is a population? In statistics, population is the entire set of items from which data is drawn for a statistical study. It can be a group of individuals, a set of items, etc. It constitutes the data pool for a study. In general, a population is the entire group that you want to draw conclusions about. Usually, when we talk about population, you think about the people living in an area at a time. But in research, a population doesn't always refer to people. It can mean a group containing elements of anything you want to study, such as objects, events, organizations, countries, species, organisms, etc. For example, all undergraduate students in the Netherlands. Or say you would like to know whether there's an association between job performance and the amount of home working hours per week in the specific case of Belgian data scientists. In this case, the population may be Belgian data scientists. However, if the scope of the study is more narrow, then the population will be more specific and include only workers who meet that certain criteria. The point is that the population should only include people to whom the results will apply. Since in this case and many others, it is impossible to observe the entire statistical population due to time constraints, constraints on geographical accessibility, and constraints on the researcher's resources, a researcher would instead absorb the statistical sample from the population in order to attempt to learn something about the population as a whole. This brings us to the topic, what is a sample? A sample represents the group of interest from the population which we will use to represent our data. The sample is an unbiased set of the population which best represents the whole data. A sample consists of some observations drawn from the population. So a part or a subset of the population. The sample is a group of elements who actually participated in the study. The size of the sample is always less than the total size of the population. Typically, the population is very large. Making a census or a complete enumeration of all values in the population impractical or impossible. The sample represents a subset of manageable size. Samples are collected and statistics are calculated from the sample so that one can make inferences or extrapolations from the sample to the population. This process of collecting information from a sample is referred to as sampling. Say you are testing the effects of a new fertilizer on crop yield. All the crop fields represent your population, whereas the 10 crop fields you tested correspond to your sample. Now let's look at the differences between population and samples with the help of some examples. The first example would be that all students in a class would constitute the population of that class. A sample would be only the top 10 students within the same class. The sample is a small subset of the population in this case. Advertisements for IT jobs in India would mean the complete search results that pops up when you search IT jobs in India. A sample of that would be the top 50 advertisements for the same jobs. Another example is all countries of the world. This represents a population of all the countries. A sample would be countries with published data on birth rates and GDP since 2000s. Next, let's look at how to collect data from a population. Data from a population is collected when your research question needs a large amount of data or information about every member of the population is available. Populations are used when your research question requires or when you have access to data from every member of the population. Usually, it's only straightforward to collect data from a whole population when it is small, accessible, and cooperative. Population data is used when the data pool is small and cooperative to giving all of the required data. For larger populations, we can use sampling to represent part of the population it is hard to collect data from. For example, a high school administrator wants to analyze the final exam scores of all graduating seniors to see if there is a trend. Since they are only interested in applying the findings to the graduating seniors in this high school, they can use the whole population dataset. For larger and more dispersed populations, it is often difficult or impossible to collect data from every individual. For example, every 10 years, the federal US government aims to count every person living in the country using the US Census. This data is used to distribute funding across the nation. However, historically, marginalized and low-income groups have been difficult to contact, locate, and encourage participation from. Because of non-responses, the population count is incomplete and biased towards some groups, which results in disproportionate fundings across the country. In cases like this, sampling can be used to make more precise inferences about the population. And for that, we can collect data from a sample. How do we go about collecting data from a sample? Samples are used when the population is large in size, scattered, or it's generally hard to collect data on individual instances within it. We can use a small sample of the population to make overall hypotheses. When your population is too large in size, geographically dispersed, or difficult to contact, it is necessary to use a sample. With statistical analysis, you can use sample data to make estimates or test hypotheses about population data. For example, you want to study political attitudes in young people. Your population is the 3,000 undergrads in the Netherlands. Because this is not practical to collect data from all of them, you use a sample of 300 undergraduate volunteers from 3 Dutch universities. This is the group who will complete your online study. Ideally, a sample should be randomly selected and representative of the population. Using probability sampling methods such as simple random sampling or stratified sampling reduces the risk of sampling bias and enhances both internal and external validity. And with that, we come to the end of a population and sample video. I hope you enjoyed this video.
Okay, I hope you've understood this video a bit. It's not too much in detail, but it's just a bit about to give you a bit idea. We'll talk more in detail about where were we? So yeah. So based on this video, now we know that when we're performing a literature review, coming back to that, this is a roadmap that shows the literature review process. So for this, the first step is developing search terms. So you would want to have search terms based on what you want to find out. So it's like it's talking about your literature review, so your project. So you will have to develop some search terms based on what you would want to search or what your, for instance, again, I give the example of, let's talk about sorry for that. Yeah, so when you're developing your search terms, for instance, you want to know, let's say the prevalence or the frequency of people who use amoxicillin, for instance, a medication, an antibiotic, and they've developed antibiotic resistance. So you want to find out how many of the population, how much of the sample develops resistance against the antibiotic. So your search terms will be based on your research. So you would want to know. So one search term could be antibiotic resistance. The other could be it could be amoxicillin. The third could be the population or the sample that you are seeing, for instance, in the NHS, whatever. So you want to see, probably you want to see community-based individuals, or you want to see people coming to the hospital. It depends upon what you want to see, actually. So these search terms are basically there. So so that you could then search for literature. If you don't have these search terms, obviously you don't know where to go next, how to start. So search terms, you search using terms. You have Boolean operators. We'll come to this, and you have filters. It's an iterative process. Third, you identify initial primary sources on the topic. So what do you want to see? Do you want to see, you're not seeing websites. So for instance, if you want to see the NHS website, these are changing drastically. So we would recommend always to see more of published researches. So that should be your first goal. So Boolean operators are, for instance, if you've put in a search term, you want to see again, the example of amoxicillin resistance. So you're combining amoxicillin resistance with so we'll talk about amoxicillin, and then you want to see antibiotic resistance. So Boolean terms actually are the word and, or, and not. So and, or, not. These are three Boolean terms that you would use, that are frequently used. So you want to see, for instance, you want to see all the literature that has been published on amoxicillin and antibiotic resistance. So it will give you all literature on amoxicillin and whatever literature is there on antibiotic resistance. If you want to see your literature, or the paper, or the published literature in the community, you don't want to see it in the NHS. So what do? You type in, for instance, if you're seeing it on Google search, or you're seeing it through PubMed, you have different databases that you use for finding literature. So you put the terms amoxicillin and antibiotic resistance, not NHS patients. So it will exclude all NHS patients. It will include only those who are in the community. So I hope you have a little understanding of what I'm saying. If you don't, please let me know. So then you read abstracts and possibly additional sections of the article to narrow your sources if needed. So you're not going to read all the articles, but you still some articles that are relevant for you. You just read the abstracts of them and some more details also. So then you are excluding some researches because you don't want 1,000 researches. You want less number of papers, so that you could probably have a handful of them. I'd say 10 to 15 articles would be fine for a good literature review. Then summarize in paragraph form important information from each source, including the citation. So your references should be there. And then you're summarizing your paragraphs. You're not writing everything. You're writing only important information, and you're summarizing them. Create a thematically focused table of summarized information. So you want a table. You're making themes out of it. Prepare for the first draft by identifying an organizational approach and writing strategically. Write the first draft and edit, proof, and polish repeatedly. So it's not a very it takes time. So you might get some feedback and you might have to fix it up. And yeah, that's all about it. We'll give more details on it. So what is a literature review? It's reviewing the literature, is a research activity all in itself, and a contribution can be made to knowledge on a particular subject through the literature review. So these literature reviews, they're after the several studies have been done, and then you would be doing a literature review to come to an agreed point regarding. So some studies may be in favor of a particular thing. Let's say some studies have found out that there. Let's again take an easy example. Some studies have found an association between, let's say, what could it be? Vitamin C and reduced infections. And some studies have negated it. So vitamin C does not help in reducing infections. So you'll be doing a literature review just to see what has most of the studies presented. Although yes, vitamin C is protective in infections. I'm just giving an example. So the literature review actually is, if it's done honestly and if it's done rigorously, it functions as a judge that spells out what is there and what is the end result. So what is it that is there on based on all the other studies. So literature reviews undertaken as a part of a thesis invariably focus on the topic that relate to the main research questions that have been raised and highlight the influential, conceptual, or empirical studies that have been conducted in the field. A literature review demonstrates knowledge about the the literature of in the field, but it is more than simply describing other authors' perspectives. It is expected to include a critical evaluation of those studies. So remember, it's not just description. It's a critical evaluation. A good review gives a novel synthesis of existing work. So you've seen different work that has been done, and you give a good synthesis of that, which may lead to new ways of looking at a subject or identifying gaps in the research. So literature review process involves identifying gaps in prior studies, and it views to locates one investigation in a broader context. So there was this study of where Silverman identifies the contents of a literature review. So what the contents are, what do we already know about the topic? This is through your literature search. What do you have to say critically about what is already known? Has anyone else ever done anything exactly the same as what is proposed? Has anyone else done anything that is related? Where does your work fit in with what has gone before or has been done before? Why is your research worth doing in the light of what has already been done? So definitely it is something that you want to add that is new. So the different features of a literature review, of a good literature review that is not biased. So it's important to be rigorous, and you'll be critiquing on previous studies. So you'll be talking about what weaknesses the previous studies had and what are the strengths of those studies. So you'll talk about different methods that were used, for instance, in those studies. Second, the literature reviews ought to supersede a descriptive rerun of what has been. So you're not doing it descriptively. You're actually progressively building towards the very research topic for being the review, for which the review is being conducted. So it's giving you a train of thoughts. When you're reading a literature review, it should be giving a train of thoughts. This includes identifying gaps in extinct literature. So whatever previous literature is there, you would want to find a gap in those literatures. the third feature is one that attracts little attention is that reviews go on throughout the duration of a research project rather than the conventional understanding that it is conducted at the beginning of a study and ends there. No, your literature review goes on as the project goes on. So yeah, so you're creating a sample of data from the findings. So data sampling, it's a statistical analysis technique used to select, manipulate, and analyze.
Hello.
Yes, yes.
Can you help me take it to the previous page, please?
Yeah.
Yeah. Thank you.
That's okay.
You can proceed.
Okay, that's fine. So, so when you're creating a sample of data from the findings, so data sampling, it's a statistical analysis technique. So it requires statistical analysis. You can not just randomly pick sample. It requires statistical methods to identify the sample. So so you're selecting, manipulating, you might do some manipulation within that sample and analyze a respective subset of data points to identify patterns and trends in the larger data set being examined. So you're not going to obviously sample the whole population as the video told you. You'll take a sample and then you'll do studies on that sample, and you'll expect, if your studies are not biased, you will be expecting the results from your study to be the same if you do that study, if you conduct that study or anyone else conducts that study on the entire population or a larger data set. And the results should be the same ideally if that's an unbiased study. This enables data scientists, predictive modelers, and other data analysts to work with a small manageable amount of data about a statistical population to build and run analytical models more quickly while still producing accurate findings. So you cannot, obviously, you don't have the amount of resources to do a sample of the whole population. So you're using just a like you can't use the whole population. So you're just using a sample. So advantages. What are the different advantages and challenges? Yeah, yeah.
Is there a specific sample size? Like if we are to rate it as a percentage, is it like 30% of the whole population we should use as sample, or more than that, or less than that? I'm just trying to be, I just want you to be specific.
Yeah, so for a sample, you would actually go for, there's some methods that you have that are statistical methods where you take the whole population into consideration and then take a percentage of the population. So it's a statistical process, and sometimes it needs some calculations also. But we'll come to that. Probably we won't want you to do so much of details. You're not going to go into so much of details or depth of finding out a sample. So just a sample of, like, let's say, if you have just obviously, if you consider a number, let's say 5 or 10 patients, you're collecting a sample of 5 on 5 or 10 patients, that's going to be too small. But otherwise, if you have a sample of 1,000 people, that's going to be too large. So something in between is the best. Otherwise, there are statistical methods that are beyond the scope of this lecture. So because it becomes too complex. But nevertheless, I will give you an example of how samples are collected subsequently. Yeah.
Okay.
So yeah, sampling can be particularly useful with data sets that are too large to efficiently analyze in full. For example, in big data analytics applications or surveys. So sometimes the surveys are very large. So you're doing a survey on COVID-19 vaccination drawbacks. So you're doing a survey on 1,000 people. So that's understood, but you're not doing a survey, you're just doing a one-time study. Identifying and analyzing a representative sample is more efficient and cost-effective than surveying the entire data or population. So that we've already done. An important consideration, though, it is the size of the required data sample and the possibility of introducing a sampling error. In some cases, a small so when you have a small sample, sorry, this is able to reveal the most important information about a data set. In others, when you have a larger sample, it can increase the likelihood of accurately representing the data as a whole, even though the increased size of the sample may impede ease of manipulation and interpretation. So sometimes you can't work on the entire sample, obviously, when it's 1,000 population sample that you're taking. So you'll need a, nevertheless, even if you can't work on that larger data set, you still can have very good results on it. So it depends how much resources you have, but you are just one person doing the whole work. So we would not want you to go for larger data sets. So, so what are the types of data sampling methods? So there are different types based on research. So the ideal one depends upon the data set and the situation, what the real situation is. So sampling can be based on probability, in which you have a random sample. This approach uses random numbers that correspond to points in the data set to ensure that there is no correlation between points chosen for the sample. So you're just picking people randomly. So for instance, you're taking you're actually let's say you're taking the views of people on the COVID-19 vaccine, let's say itself. So your plan is to do every person that comes in, you're going to take the next person in a hospital setup, let's say, or in a shopping mall, let's say. So you're going to take every second person, or in another instance, you're going to take. So there's a random selection. You're not going and actually choosing a person and saying that, okay, I'm going to check, because that may be biased. So you might choose a person who could answer your questions more appropriately. So that introduces bias. So you want to be blinded actually while you're sampling. For the further variations in probability sampling, so these are a bit more complex. There's simple random sampling, there's stratified sampling, cluster sampling, multi-stage sampling, and systematic sampling. We're not going to go into details. So sampling can also be based on non-probability. So there's some probability samples, they're non-probability, in which you don't have a random say in it. So non-probability is an approach in which the data sample is determined and extracted based on the judgment of the analyst. An inclusion is determined by the analyst. It can be difficult to extrapolate whether the sample accurately represents the larger population than when probability sampling is done. So in non-probability, you're actually going and selecting on your own. So it may be biased. So you're going and choosing some people who are more, you think they're more going to respond to your comments, rather than going for a probability sampling where you choose anyone. So when we talk about probability sampling, it more closely represents population because they're random people in the population. You see, they're randomly, there'll be males, there'll be females, there'll be all types of races, there'll be all types of ages. So when you're talking about non-probability, you're actually restricting that randomness. So then when you have results based on non-probability sampling, you can't say that based on your sample results, you would have the same results when you do it in the larger population, because that is what our objective of the whole sampling is. We take a sample and then we say that if we had to do the same study on a larger data set or on a larger population, it would give the same results. No, that is not possible through a non-probability sampling. So non-probability data sampling methods would include convenience data sampling. So data is collected from an easily accessible and available group. So whoever comes across, you just take data from them. And whoever doesn't, you don't have that data. So that's that again includes bias. Consecutive sampling is that data is collected from every subject that meets the criteria until predetermined sample size is met. Then you have purposive or judgmental sampling. This is very, very biased. The researcher selects the data to sample based on predefined criteria. Then you have quota sampling. The researcher ensures equal representation within the sample for all subgroups in the data set or the population.
We are not hearing you again. Hello?
Yeah, hi, sorry, there was a connection error here.
Okay.
Sorry. Yeah, so once this sample is generated, this sample can be used for predictive analytics. For instance, when you have a retail business, it might use data sampling to uncover patterns about customer behavior and predictive modeling to create more effective sales strategies. So whenever you want a sample, you would always have to see what is the best method to correct this sample. So convenience sampling is, for instance, you're just waiting for people to come, and whoever comes, you're going to take data from them. That is based on your own convenience. Consecutive, as I explained, is every subject that meets the criteria. For instance, if you have 100 as your sample size, you're taking every consecutive patient there or person there. Purposive will be, I want to sample only women of the age 30 and above. So that will be a purpose, and I'm having purposes sampling there, or it's based on a judgment. And quota is again taking a quota. So you want 30% of males and 40% of females in your study. So that's an example of. Is this clear? I know it's a bit complex, but we'll talk more about these things. So what is data analysis? Data analysis is the process of collecting, modeling, and analyzing data to extract insights that support decision making. So whatever data you have, you analyze that data. And there are several methods and techniques to perform analysis depending on the industry and the aims of investigation. So all these various methods are largely based on two core ideas. It will be quantitative data analysis or qualitative data analysis based on qualitative or quantitative research. So there's a difference between both of these. I'll just share a video in a bit about it. So why is data analysis important? It gives you informed decision making. So obviously the data that you have, you would give information based on that data. And then without the analysis, obviously you have the data, but how would you come to draw conclusions? So it gives you a conclusion based on your data set. You can understand where to invest your capital, detect growth opportunities, predict your incomes, or tackle uncommon situations before they become problems through the analysis. You can reduce costs. So another great benefit is to reduce costs with the help of advanced technologies as predictive analytics. Businesses can spot improvement opportunities, trends, and patterns in their data and plan their strategies accordingly. Sometimes you can target better customers. So customers are the most crucial element in any business. So by using data analytics to get a 360-degree vision of all aspects related to your customers, you can understand which channels they use to communicate with you, their demographics, interests, habits, purchasing behavior, and more. So this is all through data analysis. In the longer run, it will drive success to your marketing strategies, allow you to identify new potential customers and avoid wasting resources on targeting the wrong people or sending the wrong message. So what is the process of data analysis? Unfortunately, this lecture will have to go for tomorrow also. So we'll have a discussion on your assignment. We'll discuss your assignment, which I have done already. But it's my assumption that the assignment discussion would not require too much of your time. So it's best that I don't rush through this topic, and instead we do it tomorrow as well, because we have tomorrow's day. So what I'll do is that I'll just hold it here, and we'll talk about the different methods of, I'll just share a video with you based on what different, like what is quantitative and qualitative data. Just bear with me.
Welcome to this overview of qualitative research methods. This tutorial will help give you the big picture of qualitative research and introduce key concepts that will help you determine if qualitative methods are
Is there any sound to this video? Just asking.
appropriate for your project.
Yeah. We can hear you clearly.
Yeah, that's fine. I just want to share another video. Just a minute.
And welcome. Today we're talking about quantitative versus qualitative data. These are two terms that people often find really confusing, so we're going to break it down. We'll look at what the differences are and then talk about when you would use each in your research or analysis process. Data can generally be divided into two main types: quantitative data and qualitative data. And the root of each of these words really tells you what it is. Quantitative data talks about quantities or things that can be measured numerically. It's often things that can be either whole numbers or can be measured on a sliding scale, but they naturally have a fixed number associated with them. Qualitative data, on the other hand, talks about a quality or characteristic that describes something. Quantitative data is used when you're trying to either quantify a problem or answer a how many or how much type of question. This type of data can be counted or measured on a numeric scale. A few examples of quantitative data would include your height or your weight, or the number of children in a family. These are things that we naturally describe with a number. Quantitative data has two subsets as well. So there's two different ways we can describe quantitative data. It can be discrete or it can be continuous. Discrete data has fixed values that can happen. For instance, if we talk about the number of children in a family, you don't hear that there's 2.5 children, there's 2 children, or there's 3 children. This is discrete data. There's a limited number of options for what it can be. This is also a type of data that normally can't be defined any more specifically. So saying 2.0 children is no more specific than saying 2 children. On the other hand, continuous data is, again, still measurable data, but it can continue to be divided or refined or specified further. If we take a person's weight or height, we can continue to get more and more microscopic with the level if we had a scale or a measurement device that would get more specific. Someone could weigh 100 pounds, or it could be 100.1 or 100.15, 100.159, and it can keep getting more specific as long as your measurement tool is more specific. At some point there's going to be a lot of zeros on the end, but in most cases it can continue to divide further and further. So that's continuous data. Qualitative data describes or characterizes the thing that you're gathering information about. Think of qualitative data as descriptions where you would normally provide a word and not a number. Eye color or hair color would be qualitative data. There is a lot more subjectivity. You could create a definition of this is what brown hair means, but we all know brown hair can have a pretty wide spectrum to it. You could get more specific and say it's a blondish brown or it's a dark brown, but these are still fairly subjective terms. The same with eye color. Maybe you have blue eyes, or maybe you have blue-gray eyes or blue-green eyes. There's a lot of different options here for how to describe eye color. Qualitative data is often more difficult to measure and analyze because it is more subjective. This doesn't mean you can't analyze qualitative data though. We'll talk a lot more in depth in next week's video about how to do qualitative data analysis.
I hope this is clear, a bit clearer. So in the next session, tomorrow, we'll be talking more in depth and in detail about these concepts. I would recommend you to please have a look at what you've studied already